So, what is going on right now? AI is going on. Like, I'm in the industry for 26 years, 24 years doing Rails, and I never seen anything like this happening in this industry. Are you shocked too? Like, are you using AI? Who's using AI every day? Basically, everyone. Wow, this is really, really crazy. Yeah, thank you. So I've been doing agent encoding since March 2025, which now sounds like forever. It's just 8 months. Anyone else worked with AI in December and vibe coded quite a lot? Because that's how I spent my holiday. I went with my family to New York to, for touristic reasons. During the day, we walked like hundreds of kilometers, but then over the night, I was sitting on the computer and vibe coded 6 of my side projects over 2 weeks in New York. I want to share one of them with you, especially this one, because I built it with my 11-year-old son. It's a Fallout. I'm a big fan of Fallout. It's a Fallout-themed RPG roguelike game, and it's built in with Dragon Ruby. Are you familiar with Dragon Ruby? You should give it a try, because I had no clue what is Dragon Ruby. It was something that I always wanted to do. I wanted to build something with Dragon Ruby, but I always thought it would take me some months to build something with Dragon Ruby, because that's a new kind of library. Actually, it's a kind of different language almost. Actually, it was 2 evenings to start with this because of Cloud Code, of course. I built iOS application for the first time in my life in Swift. I never knew Swift. I built a Chrome extension. I just asked Claude to help me with my chess-related website to copy some chess-related content. Claude code generated in in JavaScript, but then I asked, can you do it in something more elegant? And then it rewrote it to Opal RB. That's Ruby. And of course, I built an OS X application too, because I want to have my own focus application. And that's the Arkansas dashboard. I'm the CEO of Arkansas, and I thought, well, finally I will build the actual financial reports and everything that helps with running the company. So I have this website is actually quite long, and it's very heavy with some charts, but this is true financial data I didn't want to show you. It's quite good. But anyway, this application was the main one that I was working on, which was actually Rails. And that was following the Rails way as it should, because that's what Irina said. The models, the agents, they are taught how to use Rails. They have good training corpus data. So I was just vibe coding without looking too much at the code until I hit the wall. So there was a moment where the agents couldn't actually help me anymore. It was at 2 levels. One level was business requirements. So at some point, I did have some business needs related to how we invoice, how we, what it means to have like accounting period. And at some moment, the complexity was already too big that Cloud Code couldn't handle this, even without my help, even with my help. And the second level of where I hit the wall with the agents in this application was performance. This dashboard is actually quite long, and it's full of heavy queries, many joins, and so on. And even though I was like suggesting, use some caching, try to be faster with this, try harder, and of course Claude responded with, yes, you're right, you're totally right, it's too slow. And then of course it didn't work anyway, so it's still slow. So let's talk about AI and Rails from the perspective of the architecture, of course. So Rails is a CRUD architecture. We are repeating the pattern of having resources which can be created, read, updated, and destroyed, which always results in similar situation in every bigger Rails project that I have seen. For example, there are GUT objects, right? Anyone have some classes, active record classes, which are over 50 columns? Yeah. I'm surprised. I expected more hands, but okay. Usually there are 2 classes like that in the project. It's the user class, of course, and it's the one other class, which is probably the main class for your application. Rails has layers like MVC. Some people add service objects, some people add repositories, some people add form objects, but we don't really have modules. So we have like layers like that, but we don't have modules like this in Rails applications. Often, Rails applications, the bigger ones, result in callbacks hell. In my experience, when I work with Rails teams, the Rails teams usually hit the wall after 2 to 5 years of doing the CRUD development and implementing some new requirements. Usually it's around 100 of active records where they hit the wall in terms of complexity. But now it can be a matter of days with agents because it's so much faster to vibe code stuff like this. So my name is Andrzej Krzywda. I'm the CEO of RubyConfTH. We specialize in helping Rails teams with their legacy Rails applications since 2007. One of the things we built, is a Rails event store. Some big projects in the world use it. The ones that try to build a different architecture than Rails CRUD, let's say. So when they started doing event-driven architectures or domain-driven design applications, they are using Rails Event Store to use it as a pubs hub and as an event storage. So in Rails applications, often the structure is missing because if you look at our active records, it's not really like you can split your active records into really some groups, some modules with some clear interface, because those active records are connected with each other via has many. So you can traverse the whole graph of your active records. That's also why many projects which try to split microservices from Rails applications, they often have really struggle, because whenever you try to split certain parts of active records to different microservices, you still have the n+1 problem across the network right now, because you still have to connect. So it's very hard to really separate the stuff. Modularity is separation plus composability. In Rails, we have composability, but we don't really have modular separation. So things are not really separated. And that was my goal always, to find a way how to solve this problem in Rails, how to have modularity in Rails. And we need multiple small modules that compose together easily. In the past, we used to need it for ourselves to have a better context in memory and better focus on what we work on. But now we also need it for AI, so that AIs have, or agents, they have smaller context. They can focus on one module at a time instead of trying to load all of the active records. Because what is the problem with my application that I hit the wall, the RubyConfTH dashboard? It was trying to load all the active records in memory to understand how is it working, and it was struggling. And my hypothesis is that domain-driven design is the missing part, because domain-driven design does bring the solution for smaller modules, and I will show you how. And many of people who are doing agent coding right now, they tell us we are no longer coders. Now our work is to orchestrate the agents, that we need to manage them, right? I agree with this. Actually, to be honest, I was more skeptical 1 year ago, but after recent months, I'm changing my mind. I see that it's actually true. We will write less code, whether we like it or not. So our job will be to become architects, because still, hopefully for some time, the agents will not deal with that very well. So that's where we can actually step in and we can support the agents. The application that I was working on for the last years, it's an open source application, so you can actually look at this application. It's 10 years old already. It's a kind of like e-commerce. It's a multi-tenant e-commerce, so it's like very simplified Shopify. It's all about, orders, products, customers, adding things to order, discounts, special pricing, taxes, invoices, shipping, and so on. So that's all implemented. And this is kind of idealistic application. So it's not really in production. Users don't use it. It's more as a picture of what's possible with Rails if you actually want to follow this route of having a modular Rails application. And this is on the Rails Event Store organization on GitHub if you want to have a look. So what I learned since March 2025, working with this application and with Cloud Code mostly, I learned that I can be fast, much faster than without agents. And I learned that I can be confident about the changes, which doesn't mean that sometimes I didn't let the hallucination slip in. It still happens sometimes. And of course, I worked on my Cloud MD. It's part of the repo. I actually pushed it today because I never really wanted to share this, but now I decided, okay, it's time to share this. It's not like some secret, but my algorithm was that whenever the agent did something wrong, I went to Cloud MD and said, that's the way, that's not how you should do it. This is how you should do it in the future. So the next part of my presentation is split into two parts. First part is to show you what it means to have a perfect DDD in a Rails application. And the second part, because the first part is not really useful for you, because then you come back to your work project on Monday and you don't have a perfect DDD application. So I'm going to show you a very simple algorithm how to bring modularity via DDD to your application. This is the diagram of this application. And there are three building blocks that probably you are not aware of, unless you did experiment with domain-driven design before. And that is read models, process managers, and domains. All of this is connected with commands and events. The numbers that I've shown here is number of modules I have of this type. So I have 16 read models, I have 20 process managers, I have 14 domains. All of that means, if I count correctly, I have 50 modules. Those 50 modules are tiny. Most of them are below 500 lines of code. Their only interface are events and commands. And in case of read models, the read model job is to display data, so the output is actually data. So it's very separated, but at the same time, very easily composable. So let's learn about read models. And probably if there is one thing that you want to remember from this presentation, it might be this thing. Read model is a very useful pattern and very unpopular for some reason. It can solve your performance issues of your views, reports, queries, and so on. So that's the next 4 minutes I'm asking you to focus if you have a short attention span. So read models are kind of like boxes of data on your pages. So this is like one page on this application. And there is an order header, and there is like a typical order list. And this is actually ideally two different read models, right? So you can think about read models as boxes of data in your pages. So if you have a view like this is a list of customers, and they can be promoted to VIPs, and they have a column for showing summary of all the orders they paid to us. We have, what it means to have a read model is to have a dedicated table, active record, that is denormalized data suited for this view. So for more complicated views where there would be like 10 or 20 columns, that would be the same, it would be denormalized, and it's always there. So whenever we display a read model, we actually grab from the database and we don't do anything else with that. So we never actually join tables on read models. That's the solution for unnecessary joining tables. We denormalize on the fly, let's say. Okay, so how does it look like in the code? I'm going to zoom in a moment. Just want to show you the big picture. This is all the read models that I have in my application. And this is like part of the module implementation. The whole read model is 80 lines of code. And let's focus on the specifics. So first of all, each read model has one active record class. This active record class is also private. Were you aware of private constant in Ruby? It's actually really cool stuff for architectural solutions where you really want to hide something so that people don't use this implementation detail of this module somewhere else. Because in Rails, people will do it. When something is public, people will access it. Of course, this can still be accessed because, of course, Ruby, but it will be a little bit, more difficult. So we are hiding this customer class from anywhere else because we don't want this to be leaked outside. This is only for internal usage. This is how we subscribe to events, because we have, what we started with is a database table, we have active record, but okay, how does the data flows in? The data flows in via events. So events are small data structures that are flowing in because it's a pub/sub. So you can see that when when the customer registered event is happening, we are calling register customer. When the customer promoted to VIP is happening, we are calling promote to VIP. So let's take a look at what is promote to VIP event handler. It's a very basic manipulation of, hey, let's retrieve some data from the event. We need customer ID. And then let's grab the active record that we have and let's update the VIP column to be true. That's all. So all the handlers are like this. Remember, it's only 80 lines of code for managing this read model. So as long as we can trust that the events come in with the right data, we are having the data to be shown. What we can see in this active record class, we don't have any validations here. We don't have any concerns. We don't have any callbacks. We don't have any associations. We are not using those features of active record. Okay, now so that's over. This is read model. That was read model. That was the one thing worth remembering, because it actually solves many of the performance problems in many Rails applications. So now let's focus on the second type of the building blocks here, which is domains. We have 14 of them. And as you can see, it's like inventory, pricing, CRM, catalog, shipments, taxes, and much more. And the idea is that what was previously in active record would be like one class, let's say product, or let's say order, or customer, because those classes very often repeat. Now, the responsibilities of this one class are split into separated domains. And we are not using active records in the domains. So what are we using there? I'm going to zoom in a moment, so don't worry about the font size. I just want to show you the big picture. So we have the list of domains. It can be in app/domains. One of them is inventory. So when I show the content of this directory, we have commands and events. And the whole domain is 220 lines of code. And the main building blocks are commands. So the input to the domain is always a command, like dear, and you can think as a domain as a business department. So dear sales or dear inventory, that's a department. Can you supply the product with quantity of 20? So that's a command. And ideally, the inventory responds, yes, I confirm stock level changed. So the product was supplied. And we have a new quantity and new stock level here. So the job of a domain code is to verify if a command can be executed and confirm it with an event. So that's the flow of data. Command is the input, and events are the output. It's very simple, from commands to events. And then you can connect it as Lego blocks. The events go to the read models, right? They populate the read model. As part of the domain, we have a building block called aggregate. This comes with the Rails event store gem. And the domain job, as I said, is to publish an event. So this is where we are publishing the event we call apply, which under the hood publishes the event. So now the last building block, process manager. So let's just conclude. Read model was taking events as input, and active record was the output. Domain, commands as input, event as output. So the last bit is that sometimes, because we have splitted these domains, sometimes we want to orchestrate them together. And we do it via process managers. And process managers, they have event as input, a list of events actually, and commands as output. So they collect certain information, it's like a state machine, and once they are ready, they will say, hey, this domain, you should do this. So for example, we have reservation, or we have shipment, or invoice generation like this. Those are like business processes. So we are using this shipment process class. Let's take a closer look at this. And we are subscribing to certain events from different domains. So from shipping, fulfillment, and stores. So this is our input. Then we have a state machine. Based on those events, in whichever order they came in, it can be asynchronous, we are deciding whether we allow to submit the shipment, so send the packages, send the order, or not. That's what we decide in this state machine. And we decide this via initializing commands. And then those commands, then they go to different domains. So you see, we are deciding that the shipping domain should submit shipment or authorize shipment, or actually both. So that's the full picture of this flow of data. And now I will show you the flow of data from the controller, so the whole cycle, how it works. So this is the controller. I'm going to zoom in a moment. This is a typical customer's controller. You have an index action, you have create action. And what is the responsibility of the controller in such application like this one with DDD? Yeah, so that's the controller. And let's focus on this last method. It's create customer command. We are calling this from the create action. So what is happening in the controller, we are sending a data structure, which is a command, to the CRM module. And the CRM responds, of course, with an event, right? So we send a command, we get an event as a response. What is happening with this event? It gets published, and the read model is interested in this, and the process manager. So the read model, customer's read model, that's the one that we looked at. So it's interested in the customer register because it needs to create the record. And that's it. The second one is more interesting because the events is also published, and process managers are also subscribed to events. So there is a process manager for onboarding. So whenever a customer registers, let's imagine we have a welcome message that we are sending to this customer in our internal messaging system. So this is onboarding. So onboarding means that when customer register happened, we are sending a command to communication, and we are asking, hey, send welcome message. So once this is the flow for the create customer, and now this is the flow for showing a list of customers. Because the customers is a very simple active record, we are just grabbing the data from the customer's read model. And that's actually the whole flow. This is how it looks like all together, a bit messy, but you can see. So the building blocks are connected together with events and commands. So now that we learned what is the whole picture in our idealistic application, let's see how we can actually use it in your application and maybe try to get those small modules as well if you like this events flow. So first of all, create those directories. That's the step. That is the first step. So domains, read models, process managers. Install the gem called Rails Event Store just for publishing the events, storing the events, and solving all the problems that you don't want to solve. Rails Event Store is free. Third step, and that's a good one. Choose one view that is complicated in your application and possibly slow, that doesn't perform well. And that will be the one that you'll try to build in as a read model. This algorithm works very well because no one will pay you for having perfect DDD, but people will pay you for solving performance problems, right? So that's how we sneak DDD into some projects, that we are solving performance problems. And by the way, that's what happens recently at one of our clients, a big logistic company. They asked us to improve their monthly report, which was taking some hours to generate. And this monthly report was the foundation for sending invoices to clients. So very important financial data. And we are following the steps of this algorithm as we usually do, just to get to the point where our read model still kept showing different data than their actual report. So we sat down with their business and we said, hey, we're using those events to build a read model, but there's a mismatch. There's still wrong data. Can you tell us what we are doing wrong? So we sat down with their finances department and they explained to us, okay, this is wrong. But then they actually realized, oh, wait. And then they asked us to show how the current report is generated, and they noticed for the last 2 years they had a bug in the financial report. So it was discovered with this events flow that they didn't charge their clients in their invoices for the last 2 years some money. Let's say there was amount of money that was enough to pay us for 1 year of work for them. So quite significant. And all we did, we just followed this algorithm. So let's say we're using this monthly report. Monthly report usually is like some kind of like almost like an Excel with many columns. And you need to define the schema, of course, for this active record that will be there for this specific read model. So let's say there will be 20 columns. And for each column, step number 5, we identify which events possibly influence this column. So let's say this column was tax value for this month, right? So tax value probably needs this and this and this event. So we want to use those events, so to identify them, because they don't exist yet. Once we identify them, let's think which domain they probably belong to. So taxes, probably, if it's about taxes, then it's probably domain name could be a taxes. If it's something about orders, it could be sales. If it's something about, I don't know, shipments, it could be shipments. So we are defining the events in the way that you saw in the previous slides. And then in step number 7, we are finding the service object or the controller where the possible event could be published, and we add event store.publish with the new event that we just created. So what's happening right now is that we have like a dual write system. The previous views and previous way of generating the reports is still working, but now we are adding another one as an addition. And as I said about our client story, keep comparing the data for each column until you get identical situation, or sit down with the business people in order to detect what they did wrong before that there is a mismatch. So log the differences and think about what is still missing. And then you can get rid of original view code once it can be replaced. So certain complexity of your active record usually disappears. Maybe even you can remove some associations. After certain read models, you extract your active records are less and less needed. They are getting thinner. So that's always a joke we have in company, like how do you get to 50 columns in your active records? You get there one by one, right? Everyone just keeps adding new feature, and what's wrong to adding a new column to a class that already has 49 columns? That's all what we do. And then the agents also repeat what we did as well. That's a nice one. If you extract some read models, you can then replace callbacks with process managers. And that's a really beautiful feeling when you are removing a callback that was always there for the last 10 years in the race application. And the completely last step in this algorithm is finally you can replace your active record with the aggregate pattern. So the active record is no longer needed as the main source. Of course, this is like a perfect heaven scenario. It's enough if you start with some read models to get used to this, and it's already a good value because you will have some modules. All right, and the last thing is like a bonus section for this talk, not really related to domain-driven design, but there's one technique that I find impossible to work without when I work with agents and Rails, and this technique is called mutation testing. Anyone use mutation testing? Okay, 3 people. Okay, 4 people. So in the Ruby world, we are very happy to have Mutant. Mutant is a tool developed by Markus Schripp, a developer from Germany. And actually, Mutant is the best mutation testing tool across any other languages. So there's no better solution in Python. There's no better solution in Java, .NET, and so on. They're all like either slower or just simply worse. So what Mutant does is Mutant keeps agents from misbehaving, or humans, because it checks whether our test coverage is good enough. And it does it much, much better than SimpleCov. SimpleCov is like a toy in comparison to Mutant. So Mutant is I'm happy to talk more about Mutant during the coffee breaks. Mutant basically keeps my agents. You can see my cloud.md file. It keeps them from changing the tests because it always runs Mutant, and it always verifies that the test coverage is good. So no tests are like deleted, commented out. That's what agents like to do sometimes. So hopefully with those techniques, we will not hit the wall again. And I'm very happy with my combination of Rails, domain-driven design, AI, and Mutant. And I hope some of you will like some smaller modules in your applications too. Thank you for your attention.